In communication, when we are sending signals, the signals are variation of voltage, but made of what? From where this variation comes? The answer is, it is the message signal from the source. Like if I am sending my voice, communicating it, then my voice is made by the vibrations of larynx in my throat, and the larynx are vibrating, and they are the one who start the wave, and that wave is again converted into electrical wave, into voltage, and that we have studied. Okay, so this frequency is a constant which remain constant whether we convert it into potential frequencies. Okay, now what type of frequency or how much frequency is generated by me, by my larynx? There is a particular value of that frequency, but the thing is that it is not a unique value, not a single value of frequency which is generated. It is a combination of frequencies. So there are so many frequencies which are generated at a time because there are so many particles of the larynx. All are vibrating. All are vibrating, but we can say there is a mean frequency of all of them. So there are two things. One is the mean frequency and one is all the frequencies. All these frequencies are around mean frequency. So if I am speaking and the mean frequency what you are able to listen is 300 Hertz, then maybe there are certain larynx in my voice which are giving 250 and there are certain which are giving 350. This is a range of the production of frequencies for my voice. So this range I will call it, this is bandwidth of my voice, bandwidth. How this name came? It's very easy. If I make a graph here and the height I show by frequency, here is 250, this is 251 through 300, and here it is 350. Now each one level represent one number, and there are so many frequencies like this, and this becomes a band. The width of the band will be more if this range is higher. So bandwidth is the total range of frequencies associated with signal, device or channel. We will study this word bandwidth with reference to these three things. The signal which is produced by the source of information, like sound I am producing from here, there may be a video, there may be a picture that is converted by a camera, that is picture signals, video signals, there may be audio signals. Then we are using telephone, we are using mobile, we are using various music systems, many devices. So we have, I am speaking, that is a message signal. We are using a device, microphone, speaker, camera, TV, all these are devices. We are using channel, a cable which is carrying the signal to my house. Then AM waves, electromagnetic waves, FM waves, frequency modulated waves which are coming from the space. Those are channels. All these three are having their own bandwidth. So first I tell you the signal bandwidth. In signal bandwidth, when I speak something, then my speech has frequency 300 to 3100 Hertz. There are few people who are making sound that may be 500, 600, 700. Normally, male voice is having frequency of 3 to 400 and female voice has frequency 500 to 700. There may be many voices which are having slightly more frequency of that. Then with this frequency, there are harmonics attached to it. If my frequency is 300, there is a mixture of 600 frequency also. There is a mixture of 3 3s are 900 also. So that makes a complete group from 300 to 900. In fact, what you are listening is from my voice, it is 300 frequency, very large amplitude, less than that 600, less than that 900, less than that 1200. These are all harmonics, and what you are listening is a combination. In this combination, some percentage 900, some percentage 1200, very low, but there is a combination, and this combination makes my signature voice. And that is why if in a dark hall there are 500 people sitting, you are not able to see anybody's face. Somebody shouts your name and you can make out, oh, it's my mother, it's my father. How? Because you are listening the combination of a frequency which is their signature. That is combination, that combination belongs to them. That is why, though our frequencies are around 300, there is the total bandwidth what we need is 300 to 3100, and there is always a combination of different frequencies with different people. Anyway, when we come to bandwidth, the human voice or the speech, we will get the full information between these two, and this range is 2800. This is bandwidth of human voice or the speech. Then if we have to talk on telephone, the telephone is used for human voice. Therefore, we have to keep our device and channel which is fit for this much bandwidth. If it is not fit for this much bandwidth, suppose I use a telephone which allows bandwidth of 1500, then what will happen? I am producing so much of bandwidth, so many frequencies, so 300 going, then 1800 going, but the voice which is contained with 2000, 2500, 3000 are not allowed by the telephone, because telephone has bandwidth of this much. So if you want to hear the real voice, the bandwidth of our device should be large or larger than the message signal. This is required. So we have done two things. Number one, the signal, every signal has got a bandwidth. Then there are other type of signals we are using, and that is music. Okay. In the music, the lower frequency belongs to the drums. They start from 50, 60. Okay. So we need, but 50, 60 has got very low energy. So to increase their energy, we have to increase their diaphragm. That is why the drums have a little larger diaphragm. Their face is larger than compared to strings or flute. So anyway, that is for the power. When we come to energy, the frequency is low. So other instruments have got higher frequencies. Sitar, flute, shahnai, all these have got higher frequency, and ghungru, it has got a very high frequency. Thinner is the voice, more is the frequency. In music, we have all the instruments. Then what should be the range of frequencies required for a music? The answer is, the range of frequency for music is the range of our ears. Yes, our ear can hear the sound up to a very large frequency, and that frequency is 20,000 hertz. The signal carrying 20,000 hertz, our ears can respond to that. They can hear it, but if frequency is more than this, if it is 30,000, 40,000, then that does not make any sense with us. We cannot hear that. So this is what we can hear, and it starts from 20. So 20 to 20,000 is the range for our ears, and therefore this is the range for music, because music is something what we hear with help of our ears. So this we call the frequency range. If we take it very close to 0, then this frequency range is 20K. That is for music. Okay, now if we go for other things, like we are sending signals. Now you see, if we want to send this music through a telephone, then a telephone should be capable to handle the frequencies up to 20K, 20,000. If we have made a telephone or our cell phone to receive the frequencies within a small range of say 1000 hertz, this is the range, then we will not hear the complete music. What we will hear? The parts which is contained in the 1000 hertz range. Suppose 0 hertz, 20,000 hertz. This is 10,000, this is 1000, and these are the others. Okay. 5K, this is 1K. In this 1K, there is a distribution of 100. Here is 300. Somebody is singing a song. This is the frequency. Okay. When the music plays, this is the frequency. A very thin and the sharp music is there. Maybe this is the frequency. Then its harmonic. If this is 10,000, its harmonic will be 20,000. If it is 5,000, its first harmonic will be 10, second harmonic will be 50. So the music is all distributed. And when you learn about the music, music has got many harmonics all coming together to us. So if our telephone is set for only 1000, you have this sound very clear coming to you. You have slight music which has got this frequency. You can hear the drums which have got this low frequency. But you don't listen to other frequencies. These frequencies become very, very less. So we say the device is not good because it is not transporting, it is not allowing all frequencies to pass through. That means the bandwidth of our signal is 20,000, okay, but bandwidth of our device is not good. If we are sending a bandwidth from here, this is 20K, but here we are using a telephone which has a bandwidth of this much. Now what will happen? All these frequencies not going, this frequency is going. This has got human voice, but the beautiful music is here. It is not passing through the telephone. That's why in the telephone you don't enjoy music. So you have to go for music systems which have got a very high or large range of bandwidth. Okay, so that is signals and device. We are using another type of signals which are coming for our television. The signals which are coming for video, that I will mention here. A video signal coming from our TV is having bandwidth of very high bandwidth, that is 4.2 megahertz. Mega is 10 to the power 6. This is only video, but with this audio is also coming, so audio is having certain bandwidth. So the total we need for TV is bandwidth of 6 megahertz for one station. You change the station, then you are going to the other frequency range which is higher than this. You go for another station, another of this. If you have got a large TV which is showing you frequency also, when you are keep on going the channels, you will find the mean frequencies are staggered and the differences are more than 6 megahertz in that. Okay, because for every one station we will need 6 megahertz, such a large frequency to contain the complete video and audio signals. Okay, so these are the range, and this range is known as bandwidth. So our speech bandwidth is very small, 2800, or you can say 2.8K. Music contains 20K. The signals coming for TV, the video signals have bandwidth 4.2 megahertz, and the audio, if you combine with this, it will be slightly more. So the total bandwidth kept for one channel of TV is 6 megahertz. So the basic thing, what is the bandwidth? It is a combination of all the frequencies being used in a particular type of signal. That range is bandwidth. Now, all these bandwidths we have discussed are which type of signals? Answer, all these are analog signals. Now, analog signal is one type of signal and digital signal is another type of signal. In the digital signals, the waveform is box waveform, this. And it is always more clear. When we make box signals for digital signals, then what is the frequency required? The shape should be box. What is the frequency required for that? See, it is again a wonderful thing. All these frequencies we have discussed are related to analog signals. Once we go to digital signals, those are box waves. Then see the relation, how it is formed. Analog signals, they have a frequency. Frequency is, how do we measure? 1 upon time period. Suppose we make a graph. This is half time period of a wave and the wave is like this. Okay. This is a sinusoidal wave. This wave is being generated by a device, by a source, information source. Along with this, it is producing harmonics of this. How the harmonics are shown here? The answer is the same is the frequency. This is the frequency. The frequency of harmonics will be double of this frequency, and that will be a wave. I will show you. Second harmonic will be like this. How much is the frequency? 2. The amplitude smaller than this. Same in this time period, when we have this one frequency, here we have harmonic. We can have another harmonic. See, one, two, three, 4, and same time period here. In this time period, we will listen one main voice, one signal having so much amplitude. Another signal which has got double the frequency with so much magnitude. Another signal which has got 4 times this much signal. So, what are the frequencies we are hearing? This is nu naught frequency for the black one, and we have 2 nu naught harmonic. Then we have 4 nu naught that is another harmonic. So, when I speak, when there is a musical instrument, there is a combination of harmonics. And if we have more and more harmonics, see how the shape of the wave is coming. This is the shape of the wave. This is a box wave. So, when we want to deal with a digital signal, then for carrying a digital signal, what is the frequency we have to handle? We have to handle this frequency, we have to handle this frequency, we have to handle this frequency, and after that maybe there is one which is like this. That is 8 and so many others. More the frequencies are added here, more will be the box shape, and if more clear will be the voice. So, if we are sending box signals, we are carrying digital signals, then signals are very clear, but the range of frequency we have to give them has to be very, very large. So, if my voice is transmitted and we have a machine, we have a device which has frequency only up to this much, then whatever is output of that frequency, you will not be able to listen the same quality through the machine what you are listening directly from me. That is what is known as live concert, because you are listening directly to me. You are listening to this wave, this wave, this wave, this wave, and there are so many other multiples. All you are coming to you, and that is a unique combination that gives the real signal what I am transmitting. But if it goes through machine, it depends upon the bandwidth of the machine, whether it can handle how many harmonics, 1, 2, 3, 4, more the harmonics it will handle, more true will be our reproduction or the voice you are listening to. That means I should use a device which have a very high bandwidth. Suppose the bandwidth is up to this much. So this is giving you all these signals, and with harmonics. More harmonics are included, more pure is the voice, more pure is the signal. So, and more box will be the shape. So for using digital signals in the box shape, what is the result we are going to approach is we need very high frequency range. For digital signals for box waves, because it contains many harmonics of multiple frequencies. So, the bandwidth for digital signals has to be very, very high. So, now you know what is meaning of bandwidth, a range of frequencies. For analog signals, the bandwidth range is quite small, and we have seen how much bandwidth is contained in our speech, in our listening of the music, and in the signals which are coming for TV. And then we have seen if we convert them to digital to accommodate all the harmonics and make it a box wave, we need a very high range. This is all about the bandwidth. And now what we have done so far is bandwidth of message signal and bandwidth of devices. Now in the next lecture we will see bandwidth of channel, the channel which is carrying the message. Okay, so that we will do in the next lecture. Thank you.